The purpose of this video is to find the Fourier cosine series of ax plus b for x between 0 to L, so that if you have a homework problem with some specific values of a and b and L, you can consult the formula at the end of this video to see if you got it correct or not. Of course, you should do your homework with those specific values of a and b and do the integration so that you know what to do. But watching this video should be a good guidance to check whether you're doing it right or wrong. Okay. All right. Here's the formula for an, and one thing that you have to be careful is that although ax is an odd function and cosine is an even function, you shouldn't be using that to simplify this integral, saying that it's 0. Ax cosine integration is 0. It's not, because the integration is from 0 to L. So you have to be careful when doing cosine series. Also for the sine series, same thing happens. You can't use even and odd. Alright, once you get the an, then the formula for the Fourier cosine series is this. So your answer should be in this format. And so there's another warning that for this formula, this is only one formula, but you have to calculate this formula twice for two different cases. One when n is 0, and the other when n is 1 or greater. Alright, so with that in mind, let's begin. So first a0, n is 0, so you plug in 0 into n, and you get cosine of 0. But what is cosine of 0? That's just 1, right? So you have just the integral of ax plus b, whose integration is easy. It's 1f x squared. X integrates to 1f x squared. Then b, which is a constant, it's bx. And then you plug in L and 0. If you plug in 0, everything is 0, so you only get some value when you plug in L. Plugging in L, you have this, and then you can multiply this out to simplify. L and L squared cancels, then you get just a single L. 2 and 1/2 cancels. So this times this will give you AL, whereas BL times 2 over L, LL will cancel, you're going to get 2B. Now for an in general, because now you do have a cosine and you have some polynomial here, you need to use integration by parts. What we are going to do is we're going to use a different format for integration by parts, which is called the tabular integration. You can check whether my tabular integration is correct or not by doing the traditional integration by parts, or you can also choose to learn the tabular integration. That will be very worthwhile to do because it speeds up your calculation by a lot. Alright, so the tabular integration, ax plus b is to be differentiated, so I put in the d column. Cosine n pi over Lx is to be integrated, so I put it in the integration column. I differentiate first, and I differentiate until I hit 0. Sometimes you don't get 0, and that's the part where tabular integration becomes a little fuzzy. It's harder, but there are ways to go around it. Okay, but anyways, we're just focusing on this problem. When you get 0, you stop, and then now you integrate. When you integrate, cosine integrates to sine, and every time you integrate, the coefficient of x, which is n pi over L, the reciprocal of this number should be brought forward because of the anti-chain rule, or you can think of it like u substitution. And then you integrate yet once again, and then sine integrates to the negative cosine. Another factor of the reciprocal comes out, so you get this squared. Now for the first column, you have to start at plus, but the signs alternate, so it's plus minus plus. Fill that in. And once you have filled that in, then you multiply things in this way. So you go across and slightly tilt down. So it's dot, dot, dot multiplied, and plus dot, dot, dot multiplied. And if you multiply that, this is the result of the integral. Don't forget the 2 over L factor. And because this is a definite integral, you still have to plug in L and 0. Plugging in L and 0 gives you the following. See, if you plug in L into this x, then L and L cancels, leaving you with sine n pi. Same thing happens when you plug in L here, you end up with cosine n pi. Then you have to subtract, and you have to plug in 0, so you plug in 0 here, plug in 0 here. Now notice that although sine 0 is 0, cosine 0 is not 0, it's 1. So this plugging in 0 does do something in this case. Okay, so you have to make sure that you plug in both L and 0, right? Okay, so what do we do? At this point, you have to know these two important formulas. Cosine n pi is -1 to the nth power, and sine n pi is 0. It's getting a little crowded, so let me erase this one and also the table. Alright, and then now let's see, we're to use this one, right? So sine n pi is 0, so that goes away. Sine 0 is 0, so that goes away. Cosine n pi is now replaced by -1 to the nth power, so this is all you get. Now I also did L squared divided by L is just a single L, and 2 is multiplied, so when you multiply this with 2 over L, you get 2AL over n squared pi squared. Same thing happens here too, because it's basically the same thing, right? And then, because they both have 2AL over n squared pi squared, now we can factor that out, and this is our final answer for AN. But it's not over yet. We still have to put these into the Fourier series. So let's write down the result and then put it into this formula that I talked about, and here is the final answer. Okay, so if you have any homework problems like this one with A and B and L some values, then replace the A, L, and then B, and see what it should be. Okay, so that would be a good way to check your homework.